Hello. Today I'm gonna explain about question 1, part A, which the question given is integrate t to the power of 4 ln t dt. First, we determine our u, which is ln t. Then we differentiate, we will get 1 over t. After that, we integrate t to the power of 4 dt. You will get t to the power of 5 over 5 plus c. After that, using the formula integrate u dv equal to uv minus integrate v du, we just substitute dot we just substitute all that I do just now. So the next step is t to the power of 5 over 5 ln t minus 1 over 5, which is I take out from t to the power of 5. So we will get t to the power of 5 over 5 ln t negative minus 1 over 5 integrate t to the power of 4 dt. So from there we multiply, which is t to the power of 5 over 5 ln t minus 1 over 5 multiply with t to the power of 5 over 5 plus c. So we will get the final answer, which is t to the power of 5 over 5 ln t minus t to the power of 5 over 25 plus c. That's all. Thank you. So part B, the question given is integrate by over 30 sin x ln cos x dx. Like usually we determine our u, which is our u will be ln cos x. We differentiate, it will get negative tan x dx. And then we integrate sin x dx. We will get negative cos x plus c. Then using the formula integrate u dv equal to uv minus integrate v du, we just substitute all that we do just now into the formula. After that, I change tan x to sin x over cos x, since tan x is equal to sin x over cos x, so that I can cancel out cos x. So what's left is just sin x dx. And then next, I integrate sin x and I get negative cos x. Since it is minus and minus, it will be plus. Then I get the final equation, which is negative cos x ln cos x plus cos x. Lastly, we substitute pi over 3 and 0. So first we set our calculator to radian. So I get negative cos pi over 3 ln cos pi over 3 plus cos pi over 3 minus negative cos 0 ln cos 0 plus cos 0. So we will get the final answer, which is negative 0.1534. That's all. Thank you.
Okay, now I'm going to explain my part, which is question 2. According to the question, it is given that x is equal to 2 sine theta. So the first thing we have to do is to differentiate what is given, so that we get dx over d theta is equal to 2 cos theta. From there, we can obtain dx, which is equal to 2 cos theta d theta. Next, we take the x and dx to substitute into the equation after. After that, we solve the square in the denominator. Next, we factor out the 4 inside the square root. Noted that 1 minus sin square is equal to cos square, so we can cancel out the square root and the square. Now we are able to cancel out the 2 cos theta. So next, we take the 1 over 4 outside the integral, and what's left is 1 over sine square theta. We know that 1 over sine square theta is also equal to cosecant square. So we change that instead. Then integrate cosecant square so that we get negative cotangent theta. And we know that it is also equal to 1 over tangent theta. Okay. Then lastly, we have to substitute back dx into the equation by using the triangle method, which we get 1 over tan theta is equal to square root of 4 minus x squared over x. And then we substitute back into the equation and we get the final answer is equal to negative 1 over 4 bracket square root 4 minus x squared over x plus c.
Hello and welcome. My name is Haziq Faiz and now we are going to solve question number 3, which is evaluate the following integrals as the above. Now, to solve this problem, we need to use partial fraction decomposition for this one. Now, how do we solve partial fraction? So, step 1, we need to factor in the bottom. If we have identified that all the denominators below have been factorized and cannot be further factorize, we need to group them into a constant or find the constant for each of those denominators below. Once we have done that, we need to multiply those constants with the denominator below. Now, after we have done all that, we have got the answer right on top of there, as you can see. After that, we need to substitute x with 0 and substitute. After we have done that, we got the answer for a, which is negative 1. And after that, we need to substitute x with 1. And the answer we got b equals to 1 over 8. Now, after we have done all that, we need to substitute those answers that we got for A and B into the equation above there, as you can see. And then we just need to solve the equation over there. And then we got that the second line over there. And then we need to um, rearrange them back to the original, which is the one that we got for A and B. We put them into the equation as such. And then after that, we need to expand those equations into like this one. Oh, okay, this one. Expand those equations. And then after we have done all of that stuff, we need to arrange those backs to find the equations. Now we have 9 equations over here, and we need to use them over here. We need to use them for the final answer. with the equations that we have, we can use them to solve these simultaneous equations over there. And after we have done all that, as you can see, we got the alphabetically ordered answers for the simultaneous equation. And then after that, we can use those um, answers and put them back into the original equation to find the answers. After we have got all the answers, now it's time to integrate them. And as you can see here, I have integrated them, and those are the answers for question number 3. Thank you, Madam Shaza, for giving us this um, question for us to solve.
Hi, my name is Muhammad Saifullah bin Nurpini and I will be explaining about question 4. The question is integrate x to the power of 4, 1 minus x to the power of 4 over 1 plus x to the power of 2. The question asks us to make the integration equal to 22 over 7 minus by pi. So the first step to do this question is we need to expand the equation so that it will be easier for us to do the long division. After expanding the equation, we will get x to the power of 8 minus 4x to the power of 7 plus 6 to the x to the power of 6 minus 4x to the power of 5 plus x to the power of 4. After that, we will divide the answer that we get from the expanding with 1 plus x to the power of 2. We need to be careful when doing the long division because many people tend to do mistake by when subtracting or add the number. So after doing the long division, we will get x to the power of 6 minus 4x to the power of 5 plus 5x to the power of 4 minus 4x to the power of 2 plus 4. And the remainder is negative 4. So we will add negative 4 at the end of the equation. Okay, after that, we will rearrange the equation so that it will be easier for us to integrate it. Uh, for this equation, x to the power of 6 and so on, it will be easier for us because it's just a basic integration. The complicated part will be this one, 4 over x to the power of 2 plus 1 because uh, it has 4 and the denominator is have the exponent. So the first step we will need to do is bring out the 4 to the front and let's see what we will do for this equation. 1 over x to the power of 2 plus 1. As we can see, we can turn it using the properties from inverse trigonometric. So it will be negative 4 tan inverse x plus c. After doing all of that, we can change the value of x to the 1 and 0, then minus it. Then we will get the answer for this question, 22 over 7 minus by pi. That's all from me. Thank you.